Yeah, calculus. I'm going to redo number 22, because when I looked at the answer they had in Pearson and Demana, that was different. So I'm going to rewrite it with this up top and do a product rule. But the product rule will have another product rule inside of it. So we're going to take this is one term, the first, and this is the second. So, so if we do our derivative, so that'd be the first times the derivative of the second and then we remember our chain rule. So it's the first times the derivative of the second plus the second times the derivative of the first, and that will be a further product rule, which is the first times the derivative of the second plus the second times the derivative of the first. This is a little bit cleaner than what we had before. Let's see. We've got a 2x, another 2x. Let's make that 4x squared. Oh, we have a 1/2. So this 2 and this 1/2 cancel. We just got the 2. So let's make that negative 2x squared, 2 to the x, and this to the 3 halves, or negative 3 halves. So that's over the square root of x squared plus 1 cubed plus, see, 2, 4, oh no, that's plus in there. That's just 2x. But this will go down to the bottom. So that'd be 2x, 2 to the x, natural log of 2 plus 2x times 2. So we're leaving out the x plus 1s here. That's all right. And this is over the square root x squared plus 1. It's a little nicer looking. Still don't like all those 2's next to each other. But what are you going to do? That will do. Let's see, we did 22 twice, 23, 24. Y equals the inverse sine of the square root of 1 minus u squared. So we're looking for dy du. Inverse sine. I think that's 1 over the square root of 1 minus x squared, but we're going to find out. So we got y equals, because I can't trust my memory for these ones. Y equals sine, inverse sine of x. That means the sine of y equals x, which means that the cosine y dy dx equals 1. That means the dy dx 1 over the cosine of y. And sine squared y plus cosine squared y equals 1. Solving for cosine of y. That means that cosine of y equals the square root of 1 minus sine squared of y. So there's sine squared of y. So it was 1 over the square root of 1 minus x squared. If that went too fast, see the previous videos. But that was our formula. So we'll apply that formula here. We just need to remember to do chain rule after the fact. So this is 1 over the square root of 1 minus x squared. X squared in our particular problem here is all of that. That's 1 minus the square root of u squared squared. And because we're taking the derivative of it, that will be derivative after the fact. That's going to be times negative 2u. Oops. Not times negative 2u. It's the derivative of all this. So that's 1/2 1 minus u squared to the negative 1/2. That's the derivative of this. So, let's do a little cleaning. So, this can go up on top. 1/2 1 minus u squared, negative 1/2. So it eventually come down to the bottom. And square root of all that squared is just going to be the square root, is the big square root. 1 minus, parentheses, 1 minus u squared. And that will be, we can bring the 2 down and this down. So that's 1 over. Now from the top, there's the 2. There's the square root of 1 minus u squared. And then here's this one. 1 minus 1 is nothing. And then we'll have the square minus u squared will be plus the square root of u squared is equal to 1 over 2 square root of 1 minus u squared plus u. They're long, but if you're methodical, they turn out. Number 25. T. Oh, equals. That's going to be both sides. T times inverse secant of t minus 1/2 natural log of t. Alright, it's got a little bit of everything in here. Got a product rule and a natural log. We're going to have to figure out the derivative of inverse secant, which I think we did in the previous video, but of course I can't remember that for the life of me. So that would be y equals inverse secant of x, which means the secant of y equals x, which means that derivative of secant is secant tangent. Secant y, tangent of y, times dy dx equals 1. So dy dx is 1 over secant of y, tangent of y. I already have the secant of y, 1 over x times the tangent of y. And tangent of y squared plus 1 equals the secant squared of y. I have the secant of y, so we'll need to solve for the tangent of y. That means the tangent squared of y plus 1 equals x squared. And so subtract 1, take the square root. Tangent of y equals the square root x squared minus 1. I don't think we did do this in a previous video. We did this one in class. I think this is listed in your book someplace as well. So that's the derivative of inverse secant. We'll just use t's. So dy dx is equal to the first times the derivative of the second. Good, we'll be canceling soon. Plus the second times the derivative of the first, which is just 1, minus derivative of natural log of t is 1 over t. Good, this is turning out simpler than I was hoping. T's cancel. That's 1 over square root of t squared plus 1 plus inverse secant of t minus 1 over 2t. Good, nice easy problem.